Hello everyone, so welcome back. In this segment, we are going to see insert operation from list implementation using linked list. All right, so we saw that how to initialize a list. So when we initialize a list, that will create a node. Okay, this node will be pointed by head pointer. All right, and this node will point to null pointer. So that means this is an empty list. But let's say we have a given list and we want to insert a value, and the default mode of insertion, it works like it only takes a parameter, and that is going to insert the data at the end of the list. Okay, so our default function, insert function, is going to insert a data at the end of the list. All right, so now let's see, we have the pointer. Pointer is pointing to the first node, and we have couple of other values in the list. Okay, like that. So our first value is 10 and second value is 20. Okay, so in this list we have two values. All right, now using the insert function, we are going to insert a item at the end of the list. So if we insert an item in this list, so it is going to insert at the end of this this node. Okay, that is pointed by the head pointer. But in this list, this insert function is going to insert at the end of the list, means at the end of this node that has the value 20. Okay, all right. So how a insert function works means we're going to target the last node. And how do we know that which one is the last node? The last node will have the pointer that will point to a null pointer. Okay, so if we find a node, all right, so if a node has a next value, okay, if a node has a next pointer that is actually a null pointer, all right, that means this is our last node. All right, and how we can access the next pointer is using the get next function. Okay, so if the get next function returns a null value, that means this is our last node. All right, so how do we find this last node? So in the linked list that we are saying again and again, means all we have is the address of the first node, which is the head pointer. Okay, so we have to start from the first node. We can actually from the first node, from each node we can actually visit the next node. So if I am here, if I know the address of this node, I can access the next node by using this pointer. If I have the access of this node, I can access the next node by using this pointer. Okay, so that's how I can traverse the whole list, but I have to start from the head pointer. Okay, all right, but this is all we have. So we are not going to actually move the head pointer. We are not going to modify. We are not going to modify the head pointer in any way, because if we lose the address of the head pointer, means if we lose the address of the first node, means the linked list is gone. Okay, the list is gone. So what actually we are going to do, we are going to have some temporary pointer variable. We are going to initialize some temporary pointer variable by which we are going to traverse the whole list. All right, so what we will do, we are going to initialize two temporary variable, current and previous. Okay, so we'll have two temporary variable, previous node pointer and current node pointer. So as we traverse through the list, we are going to traverse through the list node by node. All right, we'll maintain these two pointer, previous node pointer and current node pointer. So the current node pointer will have the address for the node that is currently being visited. And the previous node pointer will have the address for the node that was just visited before the current node. All right. For example, if this is the address of the current node pointer, okay, so if this is the current node pointer is pointing to this node, previous node pointer will point to the previous node. All right, means that was just visited, means the previous node of the current pointer. All right, so that's how we are going to move the current node pointer and previous node pointer. All right, so let's see what actually we are going to do. We are going to initialize the current node pointer as a head point get next of the head pointer. All right, so if this is our head pointer is pointing to this node. Okay, so we are going to initialize current pointer as a next pointer of the head pointer, and this one is this one, right? So head pointer is pointing to this node. All right, so the next pointer of the head pointer will be then this node, means the first value, actually the first node, the node that has the first value of the list. All right, and the previous will be the head pointer itself. Okay, so previous will be the same as the, I mean not head pointer itself, previous will be the actually the node, the same node that the head pointer is pointing. Okay, so previous will be the node that the head pointer is pointing. So that's how previous will point to the same node that the head pointer is pointing. So that will be my current node, that will be my previous node after these two initialization. All right, and now we are going to run an iteration. Each iteration we are going to move current node, okay, using the next pointer. Current will be the next of current and previous will be the current. Okay, what does it means? So in the next iteration you can see that I'm going to move previous, that will point, let's see, use a different color. So that will now point to this one, and I'm going to move current to point to the next of current. So that will be this one. So now you can see that this one is my current, this one is my previous. Okay, and that's what actually I am going to keep doing until the current value is not null. Okay, until the current value is not null. When the current will be null, all right, so then it will exit from the loop. But when the current value is null, what will be the situation? So when the current value is null, the situation will be, let's see, we have head 1 node, 2 node, 3 node, and we have null here. Okay, so that's just the first node that has 10, that has 20. So when current is null, means current is pointing to a null pointer. Okay, then what the previous will be? Previous will point to this node. All right, that's how we are actually moving our previous and current pointer. All right, so when our current is null, previous will point to this node, and this is actually our last node. All right, so for this insert operation, all we need this node. Okay, we need to use this node because we are going to insert the new node, at the end of this node. Okay, at the end of this node. All right, so this what happens until this point. Okay, now we get the node, we get the address of this node, and the address means using the previous pointer. Okay, using the previous pointer we can have the address of this node, and using that address we can now insert a new node at the end of this node. Okay, and what does this insertion will look like? All right, let's now just erase this one. What does this insertion will look like if I have a new node? Let's use a different color. All right, and I had here null. Okay, and the next this node was pointing to null. All right, so now I want to insert a new node. Let's say this node, the value is, let's say, 30. Okay, so what will happen after we insert this node? This node 20 should, instead of pointing to null, okay, this node should point to value 30. Okay, this node should point to the node with value 30, and this node with value 30 should be our last node. Okay, so this should point to null pointer. All right, so these two operations that we are going to do. So first we have to create a new node. So that's what we are doing. We are creating a new node with the value, okay, with null pointer. All right, that means it will now do, let's erase again, show you what will happen. So it's now right now it's pointing to null. Okay, right now it's pointing to null. Okay, now after this line we are going to create a new node with value 30. All right, and with null pointer as a next pointer. All right, then we're going to set the next pointer of previous node with the new node. So this is our new node. All right, we're going to set the next pointer of the previous, that is our previous, as the new node. So its next pointer was pointing to null. So instead of pointing to null, it is now going to point to a node. Okay, this node. Now let's just start from the head pointer and let's look how our list looks like. Now looks like this list has value 10, 20, and 30. Okay. Now if you insert another value, okay, that is going to again do the same process. Again start from here. Okay, come to this node. This will be now our previous node, and this will initialize another value. Okay, initialize another node with value, new value, and now 30 will point to this one, and 40 will point, means this is our pointer. Okay, it is going to point this node, and this is going to point null. All right, so that's what we are doing. We are actually using two temporary pointer, previous node pointer and current node pointer to traverse the whole list. Each time current will point to the current node and previous will point to the node that we just visited. Why we are maintaining two node? We can actually do that using one node pointer, but here actually, just to make it easy, we're using two node pointer. Okay, so that when current is pointing to the null pointer, we have the address of the last node, all right, as a previous node pointer. Okay, and the previous node pointer we're going to use, all right, as a, this is the last node, so we're going to insert the new node at the end of previous node pointer. All right, so let's just look at the simulation one more time. What will happen? Okay, and here we are also having the syntax from the code. Okay, we're also having the code here. After each line of code, what happens? So this is actually our first two lines. Okay, we're initializing current and previous, and this is our list. So in this example, we have 10, 5, 7, and 9. So we have here head pointer pointing to the first node, but the second node has the value 10, then 5, then 7, then 9. Okay, so this is the last node, so that's why it's actually pointing to the null pointer. All right, so this is our first two line of code. So current will point to the next of the head pointer. Okay, next of the head pointer, and this is this node. So next of the head pointer is pointing to this node. So the next pointer, the next node of this head pointer is this node. So current will point to this one, and previous is same as head pointer. It means when we actually assign one pointer to another pointer, that means actually these two pointer will point to the same address. All right, means now the previous will point to the same address. Okay, previous is pointing to the same address as head pointer. All right, So then we start the while loop and we continue the loop until the current is not null. All right. So first iteration, previous will point to current and current will point to the next of current. Okay. Second iteration, again previous will point to the current and current will point to the next of current. Still current is not null, so we continue. So again previous will point to the current, current will point to the next of current. All right. Still current is not null, so we continue. Okay, we'll go back to the while loop evaluation. All right, now current is pointing, now previous is pointing to current and current is pointing to null. Okay, so current is pointing to null. So now it will go to the while loop condition evaluation. It will find that current is pointing to null. That means it will go outside of the loop. All right. So, and when it is outside of the loop, what we have? We have current is pointing to null. That's not actually right now. We don't need that. But all we need is the address of previous node. Because previous node is now pointing to the last node. So now we are outside of the loop, outside of the for loop. Now we are going to insert a new node. We're going to create a new node. That's what we are going to create a new node. And you can see here in this line, you can see each time we need a new node, we are going to dynamically allocate a new node variable, okay, using the new operator. So this is going to create a new operator with the data and the next pointer will be null. So we need the next pointer null because it will be now our last node. All right, we're inserting at the end. So we are inserting the value 30 and the next pointer will be null. Okay, so that's actually our new node. All right. So I'm saying that previous, okay, with the previous, now I will set the next pointer new node. Okay, so new, let's see that this new node has address 900. Okay, so now our previous node used to have the next pointer null. Now I'm going to set this pointer with the address of the new node. Okay, so you can see that now this previous node has the address of the new node. So new node has address 900 and previous node has the address, okay, here the next pointer has, it is storing the address of the new node which is 900. Okay, so now this is actually pointing to the new node. All right, so that will be our new list after insertion. So now we have 10, 5, 7, 9 and 30. Okay, so that's how we are inserting a value at the end of the list. Okay, so this is the main idea. So all we have the address of the first node, the head pointer. Okay, so address of the first node, that means any kind of traversing, any kind of, if we want to read a value, if we want to access any particular value, particular node of the list, we have to start traversing from the first node. All right. Now this function is about if we want to insert at a given index. All right. So you can see that here we are using two parameter. The index will be given, means the position where we want to insert, and the value. All right. Now here the difference from the last example is that in the insert function we are always going to we are always going to target the last node. Okay, we're always going to target the last node and then we're going to insert the new value. But here actually we are going to run a loop until we find the position. Okay, so let's show you how actually the whole thing is working. Here also we are going to use the current node pointer and previous node pointer exactly the same way. Current will point to the current node that we are visiting. Okay, it will start from the actual head pointer of the, sorry, next pointer of the head node. Okay, and previous will be always the previous node of the current node, means that the node that we just visited. Okay, now here we are going to start a loop and we're going to continue the loop. All right, we're going to continue the loop using a initialization variable I. Okay, and I will start from 0 and I will continue until we get our index value. All right, so we are using another variable I. We are going to keep I plus plus. Okay, when I will be same as index, we are going to break from the loop. So for example, here let's see, in this list we have 10, 5, 7, 9, and another parameter we are going to need the position index 2. Okay, so for example, index start from in this example index start from 0 like array. We are going to implement it like that. So this will be our index 1, this will be our index, sorry, this will be our index 0, index 1, index 2, right, index 3. So that means we want to insert a new value 30 at index 7. Okay, I'm sorry, at index 2 means we're going to insert an element 30 at this position. So instead of 7 we're going to have here 30, and after 30 we'll have 7 and then 9. Okay, so the new list will look like 10, 5, 30, 7 and 9. All right, so what we are going to do, we're going to move our previous node pointer and current node pointer exactly like as we did in our last example. Okay, but now here we're going to have one initialization variable I start from 0. Okay, and we are going to keep updating this I value, but when I equals to same as index, okay, when I value will be same as index, okay, then we are going to actually move, we are going to actually break outside from the loop. And when I value equals to same as the index, okay, at that point our pointer, let's look at the pointer where they are pointing. Current node is pointing to the value 7 and the previous node is pointing to the value 5. So instead of 7 we have to have value 30 here. So what actually we are going to do, we are going to insert a value at this position. Okay, like here. Now here, this is our target node. Okay, so the previous node of 7 is 5. So 5 is our target node. Okay, because after 5 we have to insert 30 and after 30 we have to have 7. Okay, so this is our target node. So you can see also here at the same way previous is pointing to our target node. All right, so now what happens? So we are outside of loop. Now we are going to insert the new node. So first initialize a new node. Okay, and here we are actually using the constructor. I mean, from the node class definition, you can see we are using the third constructor. So third constructor takes a value and the address of the next node. Okay, the next pointer. All right, so it takes the value and the next pointer. What will be our next pointer? After 30 we want to have the node 7. So this node has address 500. So 500 will be our current value. Okay, and previous node will have the next pointer. It has the address 900. So 900 will be the next pointer of the previous node, like this. Okay, so what happens, it will create a new node using that. So it has the address of current. We're going to use the address of current. So it will create a new node. The address will be, I mean, the next pointer, it's going to point to the next node. Current previous used to, actually, this was our scenario from here. It used to point, previous used to point to the current node. But after this line, this is going to delete that. And this will point to the new node. Now let's start from the head pointer. You can see that 10, 5, 30. I'm just follow the next node. Okay, follow the next pointer. So we have 10, 5, 37, 9. It means we inserted the value 30 between 5 and 7 and the index 2. Okay, 0, 1, 2. Now 7 has index 3. Okay. So let me just ask you, I am going to ask you one thing. So in this insertion, what actually we are doing, we are first creating the new node, okay, and with the pointer current, all right, and then we are going to actually uh, set the next node pointer of previous with the new node. Okay, so here actually the important thing is that, like, we always just have to keep track of we always have to uh, maintain that we don't want to lose any kind of address. Okay, we have to just take care of that we are using the correct address. All right, so here we are using a lot of pointer and lot of memory address. Using pointer means we are accessing the memory address directly. All right, so that's why, I mean, when we are going to write a code using the pointer or memory address, we have to be just sure that we are using the memory address correctly. All right. All right, so I will ask you to actually write the code until this point. Okay, all the codes are given. So you have the node class definition, you have the list class definition. All right, so list class definition. So write the code. All right, so implement the insert function, implement the insert at index function. All right, and um, what you can do, actually you can have a print function that will read all the item from the list. Okay, and it is going to print all the value. So you can actually try to do that by yourself. We are going to also continue that later, and but you know how to traverse the list. uh, okay, so we can traverse the list by using two pointer, current node pointer and previous node pointer. So at each time you are traversing a node, you can actually print the value of the node. Okay, and that's how you can print all the value from the list. Okay, so try to implement the print function. Okay, so for now until this point I will ask you to write the definition of class node. All right, write the definition of class list, implement this insert function and insert at index function. So read function is also read function actually also, like, now we know how to insert, and how to insert at index means now we can traverse the list. We can traverse the whole list, or we can traverse until at some point. So using that concept, we can implement the read function. The read function given a index is also like we are going to have two pointer, will traverse the list and will stop at the point, at the position, which position the value we want to read. Okay, so when we'll reach at that point, current will point to the index that we want to read. Okay, and how we can get the data, how we can access the value using the function get data. So all the function name we are using, actually we are using the class definition that we wrote from the node class. Okay, for this node it has a get data function, and using this get data function you can get the value of this data. All right, so when I is same as the index, it will it will return you the data of that current node. All right, all right. um so modify element using index and data means you have a list. So head, modify means given a index, let's see, it has value 10, it has value 20. So given an index you can modify a value. So for example, instead of 10 you want to modify that 100. Okay, instead of 10 you want to modify that with 100. So that also, like, we know that. Okay, how to access a particular node given an index, we're going to access that node. All right, using the same concept, we're going to have initialization variable I start from 0. All right, and we'll keep doing that when until when I will be same as index. That point current node is going to point to the node that we want to modify. Okay, then just use the function from the node class definition, set data. All right, current set data should be your new data. All right, that's it. So as we are done with this modification, we can just return from here. Okay. All right. So in the next video, we are going to talk about delete function.